Alright, this is Algebraic Reasoning 1.5, Example 4. The question states, approximate radiation levels in millirads per hour near the Fukushima nuclear power plant in Naraha, Japan are shown in the table below. Now to give you a little history on this real quick. Alright, Fukushima power plant, a couple years back, near Naraha, Japan, there was a tsunami that hit a power plant in Japan. Alright, it was a nuclear power plant. And it was a big deal as to whether this was going to go nuclear, what was going to happen, all that sort of stuff. Everything was okay, but it was a big news for a while. So what they were measuring was the radiation leakage. Alright, and it wasn't too bad, but they contained it and everything's okay. But anyways, so that's just what's going on here. And so they measured it. This tells us every 4 days, the measurement every 4 days. So this is original measurement, 4 days later, 4 days later, 4 days later, 4 days later. Okay? And this is the radiation level, okay, on day 0, on day 4, on day 8, on day 16, no, 12, I mean, anyways. Okay? Determine if the data is linear or exponential, and write an appropriate model. Okay? If it's exponential, state whether it's growth or decay, and the percent change. Finally, estimate the radiation level on April 21st. So you've got 3 things. 1, they want an equation. 2, they want to know growth or decay. 3, they want to know the percent change. So based upon the questions, we're pretty sure this is exponential anyways, but let's make sure we can check. So real quick, that's a difference of 1, that's a difference of about 4, that's a difference of about 7, 8, 9, 10, that's about 5, that's about 10, that's about, I mean, I'm just judging real quick. Those are pretty far off, and this one's like 30. Alright, so already you're probably pretty sure that's not linear. So exponential, so let's do 39.8 divided by 71.2, and we got 55.5589, so we'll do 0.556. I basically just took this one and divided it by the previous and got 0.56. Okay, 22.3 divided by 39.8, and you get 0.56. Oh wow, exact same thing. 12.5 divided by 22.3, you get, again, 0.56. Wow, 7.1 divided by 12.5 is, again, 0.568, so this is really 0.57. Alright, 3.9 divided by 7.1, that is 0.55, and last but not least, 2.2 divided by 3.9, let me guess, 0.56, yep, 0.56. Alright, so those are your common differences. Alright, so first things first, this is exponential. So our starting point is 71.2, and our B value, so we got to add all these guys up over here and divide, now let's use an actual pen, not the box, divided by 1, 2, 3, 4, 5, 6, because there are 6 differences. So 0.56 plus 0.56 plus 0.56 plus 0.57 plus 0.55 plus 0.56, that's 3.36. Divided by 6 equals, hey, who guessed it, 0.56. Alright, so our B value is 0.56. So that's all the information we need. F of x, or your y in this case, is 71.2, because that's our starting point, times 0.56, that's our ratio to the x. Alright, that's the first question it asks. The second question it asks is growth or decay and percent change. Ooh, I forgot to add something. They want to know on April 21st of 2011. Oops. They want to know growth or decay. Well, B is less than 1. Remember, when B is less than 1, it's decay. So that's less than 1, so it's decay. Alright. 0.56, remember to find the percentage, we take your B value. We find the difference between your B value and 1, and then we multiply it by 100. So 0.56 minus 1 is 0.44 times 100 is 44. So it is that's actually negative 44. So it is a 44%, and that's a decrease. That's question 3. Question 4, they want to know on April 21st, 2011. Okay, so April 21st, they want to know on, not 8/21, why did I write 8? 8 is August. It's currently August, that's probably why I put an 8 there. 4/21. So they want to know on 4/21. Interesting. Okay, so let's start counting down to that. 6, remember these are 4-day increments. So 7, 5, 6, 7, 8, 9 would be the 19th. And I'm going to put 8 down here because I think that's going to be a spread. 4/23. They want 21, which is right there. So that, just like we were talking about later, so this is 20, 21, 22, 23. That is halfway between, so that is at 7.5. That's an x value of 7.5 because 21 is halfway between x of 7 and x of 8. So here we go. Y equals 71.2 times 0.56 to the power of 7.5. 71.2 times 0.56 to the power of 7.5. And we're going to estimate it to be, so x of 7.5, which that's a legitimate x value, is 0.9 millirads. And there you go. Try the others on your own.